Hi everyone, see you again. Today I want to go to lesson 2.4. Okay, let's see the notes. Make sure you got the notes and take out. Okay, come we go and see the first one. We like to introduce what is this topic. Okay, this topic is an electromotive force and also the internal resistance. What we learn about the 2.2, we just learn about a potential difference and also the current. Okay, we never touching about the internal resistance of the battery. But 2.4, we will including. So for here, we need to using another formula to calculate the resistance. Okay, now we go and see the first part. Okay, first part they introduce about the EMF and also what is the definition and also the unit. Okay, come, let's see here. Okay, first one, electromotive force we can write as a EMF. So EMF, the same like the meaning of the potential difference. But the problem is, they just happen when there's an open circuit. So from your notes, from here they say EMF is a potential across the cell, or you say the source of the electricity when it is on the open circuit and no current supply. So that means what situation we can measure the EMF? When the situation is a circuit, there's a no current to pass through, then you got battery. Then the battery join with the voltmeter, then we go to read when the situation is open circuit. So that means now the voltmeter, they will show the reading of the battery. What is the potential difference of the battery? So this one we never call potential difference, we call it as a EMF. So let's see the circuit here. Okay, the circuit they join with the potential difference, join with the voltmeter in parallel. Okay, this one is a bulb. Now the situation is open circuit. That means the switch open. Switch open means no current. When no current, okay, but the voltmeter, they still can show the reading. The reading is represent what? The reading is represent the voltage of the battery. If I say now the battery is a 6 volt, so that means now the voltmeter that show the reading is a 6 volt. This one 6 volt is represent what? They represent with the voltage of the battery. So this one, the name we call it as a EMF, electromotive force. Okay, so now we go to introduce what's the electromotive force. Let's see the definition. Work done by the cell to drive the 1 coulomb of the charge. Okay, to driving 1 coulomb of the charge around. Okay, let's see this diagram. Around what? Around the whole circuit. Whole circuit. That means they start from the battery, they move until the end. Okay, remember potential difference. Potential difference, the definition almost like this. There's a work done to move 1 coulomb of the charge from one point to another point. That one just point to point. So that means they just want to measure the bulb only, either resistor. But EMF, you need to change that work done from where? From the cell, mean battery. Driving also 1 coulomb of the charge. Now is around the complete circuit. Okay, this one is a different. That one just for certain resistor you want to measure, but this one they want to measure the overall circuit. So this one we call EMF definition. So from here they also show for you what's the EMF. Okay, there's an electromotive force defined as a work done by some source in driving 1 coulomb of the charge around the complete circuit. Okay, then we go to the symbol. The symbol for the EMF, okay, there's a capital E. Then after that, the unit, same like potential difference, there's a volt. You can write as a V, you also can write as a joule per coulomb. Okay, that one is a unit for the EMF. Okay, the next one, we need to introduce an open circuit and also closed circuit. Okay, let's see the open circuit. Okay, open circuit is a situation, okay, when the switch is still open. Okay, the switch is still open, that means no current flow through the circuit. Then the voltmeter will show the reading. That reading is stand for EMF. This one is an open circuit. So that means what situation we can read for the EMF? When the situation is open circuit. Okay, then we go to see the closed circuit. Okay, when closed circuit, you can find it. The switch is closed already. Okay, the battery is still parallel, but now the voltmeter, remember, the voltmeter always join with the battery. This one also same. The voltmeter is joined with the battery. For this one situation means we want to measure is the EMF. If the voltmeter you join with the bulb, that situation is we want to measure potential difference. So from here you find the battery parallel join with the one of the voltmeter, mean this one situation you want to measure the EMF. But now closed circuit. When closed circuit, actually we cannot read about EMF already. Because EMF just got open circuit. When closed circuit, okay, means the current can flow. When the current flow, this one voltmeter reading, they will drop. Okay, they will drop. So current flow, voltmeter reading drop. Okay, then this one voltmeter reading actually what's the meaning? They show about potential difference across the bar. So that means when I just close the circuit, the voltmeter show the reading now is this resistor voltage. Okay, so that one is a closed circuit. So we can call it as a normal potential difference when I just close the circuit. So from here, let's see the closed circuit diagram. So from here, I can make a conclusion. EMF sure bigger than potential difference. Agree? Okay, EMF is the actual one. Actual the battery volt. So when I close circuit, the voltage they come out, they go to the bulb. So that means this one we sure will smaller than the EMF. Agree or not? So from here, you can see the diagram that show you what is that. When closed circuit, the reading of the voltmeter, that's a V, they must less than the EMF. Okay? So when the cell or source electricity in a closed circuit, current is flowing. Number two, the potential difference across the cell, they will drop. Okay, this one we call what? Potential difference across the cell. Or you say across the battery. Okay, so this one across the battery and also the bulb lah. So when I close circuit. So from here we see what's the differences for the EMF and also potential difference when closed and open circuit. Okay, let's see the first one. Okay, when open circuit, they say no current flow. Okay, everybody agree, no current flow. Okay, voltmeter, they show the reading is 1.5. This one 1.5 actually is what? The 1.5 is a EMF. Agree, Okay, then number 3, they say EMF is a reading of the voltmeter, which is connected direct across the terminal to the cell. Then the EMF is a 1.5. So this one is what they want to explain about open circuit related with the EMF. Then we go to second diagram. Second diagram is closed circuit. Okay, when closed circuit, you see the current start to flow. Okay, current start to flow. Then you also can see the diagram. Okay, the diagram here. Okay, they got one, this one actually is a battery. Okay, inside the battery, they got E. Can you see the capital E? Capital E stands for EMF. After that, inside got one smaller R. That means this one is a battery, also got resistance. So this one is what we need to learn today. Now your voltmeter is parallel with the battery. So from here, now when you close circuit, the current that start to flow whole circuit. Now we got two resistors when you close circuit, agree? One is a small r, another one is a capital R. So from here, I want to introduce a name first. Smaller r, we call it internal resistance. Okay, the outside the R, example, you want to put the bulb or you want to put the normal resistor, we put capital R. This one we call it external resistor. Okay, so we differentiate first. So from here, when your current just start to flow, that means the current will flow internal resistance and also external resistance. Okay, then the reading of the voltmeter, they say they will drop. Okay, they will drop. So a little, drop a little only. If a lamp is connected in the series and also the cell. So you connected in a series means your voltage you need to share, is it? Because this one is a series circuit. This one small r. This one is a capital R. Now both in series circuit. So that means now your voltage you need to share. So from here, when the current just pass through, your voltage will be dropped. Okay, now the voltage will drop. So if the voltmeter they show the reading is 1.2 volt, so that means the potential difference across the bulb, across the lamp now is 12 volt. So they hilang how many? They hilang 0.3 volt. Okay, so later we need to explain the hilang volt actually using for what. Okay, so from here we go to explain the closed and open circuit. Now we go and see the following. They say the cell in the battery. Let's see the cell in the battery. When cell is joined together from the battery, two factors are affected by the way the cell are connected. Okay, let's see the first one is an EMF and also the internal resistance. Okay, first one diagram they show there's a series, all in series. Okay, in series is okay. In series, for the potential difference with sharing, is it? So total E is 3E. Okay, if you say total resistance is how many? There's a 3R. Okay, this one is in series. Okay, we can plus together. But in parallel, okay, let's see in parallel. Okay, let's see in parallel. We're going to see that this one is a E. This one E. Okay, parallel, that means the voltage you are the same, is it? So from here, total E is how many? Total EMF is a E only. Because everyone should be the same. Okay, how about the total R? Total R will become 1 over R plus 1 over R plus 1 over R. Then the R should be divided by 3. So that one we call it, 1 over 3. So this one is a total R. Okay, same like what you do the calculation for resistance. Okay, EMF and also normally same like the potential difference. The calculation should be the same. Okay, let's see the last one. Last one in parallel, but every parallel they got 3. These two join together lah. These two join together. So let me draw first. Let's see this one. Let's see this one. Okay, now it's parallel and series we join together. We count by series, one row by one row first. Okay, this one will become the 3E and also the 3R. This one also same. This one also same. So that means now the situation is become parallel. 3E, 3R. 3E. Okay, so the situation become like this. We convert already. So we do the calculation. This one is a parallel. So the voltage should be the same. So final total E should be 3E. Okay, never changes. How about the R? So total R, normally we do the calculation is 1 over 3R plus 1 over 3R plus 1 over 3R. Agreed. So remember, before that we learned about the resistance. If 3 resistance should be the same, 8, 8, 8, what you need to do? You take the 8 divided by 3. So that's the answer. So from here, 3R, 3R, 3R. We take the 3R divided by 3. So the answer, 1 ohm. The R become 1 ohm. Okay? So understand, not 1 ohm, there's a R. Okay, total R become R. Okay, so this one is just want to show if the EMF, the battery join like this, how we do the calculation. Okay, then we go through to the internal resistance. Okay, this one is the second one I want to explain. First one EMF, the second one is internal resistance. Now you can see what is the internal resistance. Actually, internal resistance is inside the battery. Because battery, they also got some resistor we need to overcome. But the resistance is very, very small. So This one internal resistance, they just affected a little bit for the potential difference. Okay, come we let's see the diagram. Okay, this one is a closed circuit. Okay, we got one voltmeter. Now the voltmeter parallel with the battery. Okay, this one is a battery. So battery normally we draw this one. We never show this one. Okay, suppose inside the battery we got one smaller resistor. So this one we call internal resistor. So this one is a EMF. The EMF means original voltage of the battery. So this one we call capital R. Okay, so this one is a situation about the internal resistance. You can see about the diagram. I will show you. Now we're going to see why the potential difference will drop. This one is one of the questions they will ask. Why open circuit is 1.5? When I close circuit, they become 1.3. Why they will drop? So now they must be related with the internal resistance. Okay, come we go to now see the answer. Okay, why the potential difference across the battery they will drop when it is supplied the current in that battery has a resistance. Okay, now the drop in the potential difference across the cell is caused by the internal resistance. Now, internal resistance in the battery across loss of energy or drop in potential difference across the battery. Why? Because potential difference, they need to overcome, although a little bit resistance, they also need to overcome. So that's why they use some energy, also same, use some energy, move the charge, cross over the resistance. So that means they're using a little bit voltage to overcome here. When they just overcome means they will lose a little bit voltage. Convert to what? Convert to the heat energy. So from here is number 3. Sum of the energy per charge. That means there's a potential difference, energy over charge. Okay, by the battery they provided will be used to overcome the internal resistance of the battery and also change to the heat energy. So mean the energy overcharge, they will flow through the circuit, then overcome the resistance, produce what? Heat energy. So the battery will become hot after long to use. So from here in the practice, potential difference of a battery they provide an external circuit will always be less than the EMF. This one we call external circuit. This one we call internal circuit. So that means now the potential difference when they cross to the bar, you find it, the potential difference will be dropped. Okay, the potential difference will be dropped compared to the EMF. So from here we cannot say, oh, because of the external make the potential difference, the EMF drop. No, we cannot say the external cause the EMF to drop. We just can say it's a internal resistance to cause the EMF reading drop it. Okay, internal resistance to cause. So from here, the conclusion is EMS is always bigger than the potential difference. Then the reason is why? The reason is because the voltage used to overcome the internal resistance, then to produce a heat energy. So this one all just happened inside the battery. Okay, now we go and see the differences. Okay, potential difference and also EMF. First one, the sure difference is a definition. Okay, let's see the definition. Okay, I show you the diagram. You can see the first one, there's a potential difference. Electrical energy, there's a transform to other form of the energy. When one of the coulomb of the charge flow through the component in the closed circuit, means they just flow one point to another point. Okay, the next one we go and see the second diagram. There's a EMF. EMF is stand for electrical energy that given to one coulomb of the charge flowing through the whole circuit. So that means they also moving coulomb of the charge, but now it's a whole complete circuit. Okay, that one is the first differences. Okay, the second differences sure is a connection. Okay, for the EMF, the situation you want to count the EMF, connection of the voltmeter sure is parallel with the battery. Okay, but normal what we learned in 2.2 and 2.3, the voltmeter where we put is parallel with the resistor. That one is the differences for the diagram. Now we're going to see number 3, the differences. Okay, for the EMF, they use the reference of the source of the electrical energy. They're from where? The source is from the battery, electrical energy. Okay, used in the reference for electrical component in the circuit for the potential difference. Potential difference, they're just talking about the component. Okay, but the EMF, they're talking about the battery. Okay, electrical energy from the battery. The next one, number 4, the represent by the voltmeter reading when there's an open circuit. That one is an EMF. Okay, another one is a potential difference. They show on the voltmeter when the situation is closed circuit. Okay, the last one is both also the similar. They measure by using the unit volt. Okay, using the volt, or you say the joule per coulomb. Okay, so this one is what I want to introduce, potential difference and EMF. What's the differences? Okay, then we continue with the relationship. Relationship to what we learned today. There's an EMF, potential difference, current, internal resistance, and also the resistor. Okay, that one is external. Okay, let's see how we create the formula. Okay, come, let me start to the relationship. Okay, you can see the circuit inside here. The voltmeter parallel with the battery. Okay, now we're going to see this one situation. They just want to test about the activity, then related with the formula about the EMF. Okay, let's see the first one. They say switch S is led to open. Okay, open the switch S. What happened to the bulb to observe? Okay, number 2, they say the reading of the ammeter and voltmeter, you also need to record it when they open circuit. Okay, after that, the last one, they say close. You close the circuit, so also same. What happened for the bulb and reading for the voltmeter and ammeter? Okay, refer to the table. Okay, state the bulb when they open. Open sure cannot light up, they light off. Okay, they say the ammeter reading is 0. Sure is a 0 because no current to pass through. Okay, voltmeter reading. Okay, now the voltmeter reading is 3 volt. So we understood this one 3 volt, another name, what we call it? EMF. Okay, EMF. Okay, the second one, when I close, I find it the bulb light only. Okay, the bulb can be light up. Reason, because got current to flow through. Okay, now they show you the current is 0.2. Okay, now the current 0.2 ampere. Okay, the next one, then they say now the voltmeter reading become 2.6. Means this one 2.6 is what? There's a potential difference. For what? For the bulb. So that means now you can see, okay, this one is a potential difference, this one is an EMF. Means between here they drop already. Drop already the voltage used for what? Used to overcome the internal resistance. So from here we got 0.4 is drop. This one we call it what? Potential different drop. Okay, potential different drop. So this one potential different drop sure is related with the internal resistance. So remember the formula. V equal IR. This one is what we learned before. Okay, now the voltage drop. Voltage drop, the formula is I. Current should be the same because there's a series, but smaller R. Because this one drop, they're using to overcome is the internal resistance. So from here, I can create the formula like this. Okay, 3 volt equal 2.6 plus 0.4. Okay, suppose like this. So the formula I want to create is EMF equal to the potential difference plus current pass through and internal resistance. So this one is an EMF equation. So another equation also same. You can write E also equal. When the question never provide potential difference, so I need to split. This one become IR. So both I should be the same. I take out. capital R plus small r. So this one is another formula for EMF. This one is when the citation, they provide the potential difference. So we can use in this one. If the question never provide potential difference, they provide the external resistance. Okay, we can apply this formula. Okay? You need to start about the example 1. So every question we also need to read properly and write the information. So from here, let's see the example 1. Let's see example 1. The info, what they tell you. Okay, the first one, they show the circuit. Can you see the voltmeter is parallel with the battery? So this one citation they want to measure is a EMF. Okay, info, when open circuit, the volt is 1.5. This one 1.5 understood, sure is a EMF. When it close, 1.35. So this one 1.35 also very clear, there's a potential difference. So from here, when you close circuit, you find it, the current becomes 0.3 ampere. So now the question A, they want to find EMF. So understood EMF, the answer sure 1.5. Okay, R, how to find internal resistance. And the last one, how to find the external resistance. So student, you need to try how to solve the question B and question C. Okay, before I show you the answer. Okay, everyone, you finish about your question 1, is it? Now we're going to see the example 2. Example 2, the diagram example like this. Okay, you see this one diagram? The voltmeter never parallel with the battery, but this situation we also want to measure the EMF. Okay, example, the switch is here. Okay, if I open circuit means this one switch is open. So now the battery, they also pass through the voltmeter. So they never touching about the resistor. So this one situation, we also call it, they want to measure the EMF. Okay, although the voltmeter I never put here, they put at the bottom. So this one situation, we also say they can measure the EMF. Okay, so from here, the question they give you the info, EMF is 1.5. Then when closed circuit, the current is 0.5 ampere. Then the voltmeter reading will become 1.2. So understood this one is potential difference, this one is an EMF. Now, the question they want to find two things. A is a external resistor. Last one is a internal resistor. We still apply the two formula, then we see how to solve it. You can try first before I show you the answer. You can want to see first my answer. You can try, you stop first, you pause a while, then you do first. Then after you finish, you can play again, then you see what is your answer. Okay, like this is more challenge. Don't just see, then you just copy. Finish for example 2, then we go example 3. Okay, example 3 is some special of the question. Okay, let me read together. An accumulator, they produce a current that's a 4 ampere. When it's connected to the resistor, there's a 2 ohm. Resistor means this one is an external. So from here they say same accumulator. So that means at the same time, one of the accumulator just want the measurement. They can measure the current and also measure the resistance. So from here, this situation is, first round, I do the measurement. Okay, I produce 4 ampere and 2 ohm. Okay, now they say, using the same accumulator again, now I want to measure the second time for the different thing. Okay, so from here, which is never changes. If you're using accumulator, that means the battery already is there. They never change one. You just, maybe you change the resistor, you change the bulb. Okay, you first bulb, then later you use another bulb to test. So from here you find it, internal resistance is never changed because there's the same battery. Okay, number 2 is EMF also never change because you just plug out, take another bulb, then you go to plug in. So that means accumulator you want to test is the same thing. This one is a keyword, same accumulator. If same accumulator means the situation, EMF and also internal resistance is never changed. So from here, we need to create the equation. Okay, the first one, because we never provide the V, is it? From here, we're using the second equation. Using the I, capital R plus small r. So we're using the second equation. So the first situation, we see the first one. EMF we do know. Current is a 4. Okay, R, there's a 2 plus small r. So this one, I put equation 1. Okay, then we're going to see the second equation, equation 2. There's a 3 ampere. Internal resistance, don't know. External, there's a 3. 2. Okay, now we need to solve by simultaneous to find what is the E and also what is the R. So from here, we just take number 1 equal to number 2. Okay, we just 4, 2 plus R equal 3 plus R. So we just go in 4R, 9, 3R. Okay, so this one become 1R, this one is 1. Okay, so I find it, my internal resistance just 1 ohm. Okay, now I finish my R, then I can take my R, apply to the equation 1 to find what is the E. Okay, let's see, I take R as a 1 ohm in the equation 1. So the E equal 4, 2 plus 1. So there's a 12 volt. This one is your EMF. This one is your internal resistance. So this one is another question format. Okay, you can solve it by using the simultaneous. So now we got 3 examples here. So make sure you can solve it. Okay, the last part we want to see the graph. Using the graph to relate it with the formula. Okay, let's see how to do it. Let's see your notes. Okay, your notes that show about the 2 graphs. These 2 graphs, we also can find out what is the EMF and also what is the internal resistance. Okay, make sure the graph they got label the coordinate lah. If not, we cannot do anything. Okay, let's see the first one. Okay, first one, we're using the original graph equation. Y equal mx plus c. This one is a standard. So from here, now we go to change. We never using y. Now it's a v. So v equal mi. Okay, x become I plus c. C understood, show here. Is it y-intercept? So from here, we need to create the equation followed by the EMF. Okay, EMF equation we write first. This one is an EMF equation. Now I need to compare. Okay, from here, better I using the first one. Compare, because this one don't have the capital R. It just got V. So I want to move this one equation, make the pattern same like this one. So that means your V must put another side. So from here, I exchange. So I move the V come here. So V equal E minus IR. Okay? So now I want to make clear some more. V equal, I move the IR come in front. Okay, minus R, then I put the I like this. So actually it's the same. Then plus E. Okay, now I want you to compare this one and this one. It's a V. This one also V. Can you see this one is an I? I is stand for x-axis. So can I say M equal to the negative R? Actually, gradient is a negative R. So how about the y-intercept? Y-intercept actually is a. So if this one graph that show you the reading, means this one is a EMF. So another one, you want to find the R, internal resistance, you need to find this one gradient. This one gradient show negative gradient because they drop. So finally your R is no negative. Because you find the answer got negative, is it? The question they just want the R. So from here they got mentioned E is an intercept, then the R is a gradient for this graph. Okay, then we go to the another graph. So another graph by using this one equation, because now don't have any potential difference. So we just create R equal M1 over I plus C. So that means M is a gradient. Okay, so from here I need to take this one equation to create the pattern like this. So what I need to do, the I must be divided. So I move the I to come here. So R plus small r equal E1 over I. Okay, I divide the I. So from here I left R, E1 over I minus R. Okay, so from here understood, E is what? E is stand for M. E is gradient. This one gradient sure positive. Okay, now negative R is stand for y-intercept here. This one reading sure negative. So the answer they just want to find the R. So your final answer cancel the negative. So understand? So this one question we don't have any calculation. They're just using the equation to represent each other. So our lesson is finished for the 2.4. So what you need to do is a tutorial question. Later I will show you what's the answer. And also the objective, we got 10 questions only. So you try first. Later I will show you the answer and also the structure question. For the science 3 student, you got one structure. For the science 1 student, you got another question. There's a 12, question 12. So I will show you later. So make sure you understand. If you do know any question, then you can PM me in Telegram. So thank you for your watching. Okay, have a nice day. Thank you everyone.